Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. So I had a tweet this morning that I thought would be interesting to discuss with you. So I asked people in a poll, what's keeping you from migrating your server-side stuff from Java to Kotlin? And the options I provided were insufficient value, company policy, technical difficulties, or other. And asked people to reply. So 54% currently, with 66 votes, said insufficient value. And so I wanted to dive into that a little bit more. I'm convinced that there's sufficient value in Kotlin to move from Java, but apparently that's not everyone.
Well, but you were asking a very specific question. You were saying, why not take your server-side application and move it over?
True.
They already have a server-side application that's working, presumably in Java. And it's like, what is the benefit of them? And they have a crew of people who know how to maintain it. So what is the benefit of taking that and rewriting it?
That's a good point. I didn't ask, why did you choose Java over Kotlin for a new application or
Totally
something?
different question.
Yeah. So I can see that while I might be convinced that Kotlin has sufficient value over Java for me to use, is it sufficient value for me to migrate a Java application to? And yeah, I can see that that's very different.
That is because that's could be a lot of work. There's a lot of debugging. You have something that works, and if it goes wrong, you can go in and find the problem.
Well, and do you remember long ago I came up with a definition for, maybe not a definition, a way to talk about what enterprise software is?
No.
Because you and I have discussed this a lot. It's like,
Well,
what is enterprise software?
Okay,
What does that
I
even mean?
don't recall it, so I would like to hear what is.
So do you remember DHH's, I'm pretty sure it was DHH, but maybe somebody else invented this, which was move fast and break things, right? I think I'm saying that right?
I thought that was Facebook.
Maybe it was Facebook.
And they certainly break things.
So maybe it wasn't DHH, maybe it was Mark Zuckerberg that said that.
I think that is Facebook. But anyway, DHH had something too.
Yeah.
So
my way to talk about enterprise software related to that is move slowly and break nothing. Is I think kind of what captures the difference between enterprise software and non-enterprise software.
See, because my definition, after many years of being confused about what it is that it's trying to figure out what is common among all the things that these companies need, so that it can, and then they need to adapt it to their particular needs. And so there's things that are common, databases and connecting with the world and UI and all that kind of stuff. There's all that there. And then there's the customization part.
Yeah.
And so I think that versus off the quote unquote off the shelf software, which just does what you need it to do. This is like you have to take these pieces.
So a unique trait
to them.
of enterprise software versus non-enterprise software is the need for dramatic customization of.
Yeah, and the reason that we had all these different libraries, so many of them which were just shots in the dark. I mean, EJBs were that was a ivory tower analysis, and then they pushed it on everybody, and it cost billions of dollars of loss over the years because somebody thought it was a good idea. And so it's like, well, how can we find what changes and what stays the same? And then when you customize enterprise software, you're adapting the things that changes. And of course, you never know for sure. So that's why
business is always changing.
Business is changing, needs are changing. You can anticipate some needs and say that, oh, well, that's in the common base. And then here's the stuff that we change. But anyway.
So back to the move slowly and break nothing. I think that enterprises, one of the kind of definitions or key traits of enterprises is risk mitigation. And so I think it's very central to a lot of enterprises is try to mitigate as much risk as possible. And so I think where that comes out in software is that change is risk. Change involves risk. And so part of the reason why enterprises move very slowly in technology adoption is because it's a risk to make a change. If it's working, why change it? And this is why we still have all sorts of mainframes running COBOL with very critical systems on them. It works. Let's not touch it.
Yeah, plus there's the sunk cost fallacy, which I think is a big thing here. It's like, because you look at your COBOL program and you go, we spent millions of dollars developing that, and so changing it is expensive. And so the idea is that, well, if we were to rewrite it in a new language, that would cost us the same amount.
Yeah.
And have the same impact. But it wouldn't, because A, they know what the system is supposed to do, and B, you're using much more sophisticated tools.
That's right. Hopefully better, more modern.
But we've been fooled before. I mean, you remember Ada.
Yeah.
Ada was supposed to solve all the problems, and the Department of Defense got behind it, just like it did with COBOL.
Yeah.
That is COBOL would have faded away if the DoD hadn't said, well, this is clearly the good language, and so we'll get behind it and pushed it on a whole bunch of companies.
Yeah.
So, we have a bad history with the DoD deciding.
Well, I guess maybe the more meta-related point is that we've been burned by being told, oh, this thing is better and you should move to it. And so we've been burned before, so that's made us even more risk averse.
We've been burned many times.
Many times.
I mean, there was, and it's, you get a sense of the smell of this thing. This is why I'm skeptical of the low code, thing, is because on one side it's like, sure, a system that allows you to put together an application with less effort, I'm all for that.
Yeah.
But when the marketing people get excited about it, it just stinks to high heaven.
That's the red flag.
It is the red flag.
With any technology, when the marketing people get excited about it, oh man, run away.
Kinda. It's just let's just say it's worrisome. I mean, the last time I really saw it was the AI revolution in the 90s, which nobody remembers because it wasn't.
Yeah. And SOA, man. Marketing got so excited to have that term. SOA, you need your SOA.
Oh, and
you're so
well, and then they also had
RA. We got excited about RAs.
Well, and back then client server was a big thing, and it's like that was.
It's weird that marketing really likes to have like a term. It's like they find that term. HTML5, Web 2.0. So
it's a package. It says we have this thing, you want it.
And there's so much value you need to rewrite into this thing.
And that is all packaged in that term.
Yeah.
And
I've definitely seen this sentiment in terms of Kotlin, where people are like, oh, you keep trying to tell me Kotlin's better, but I just don't trust you because I've been burned by this before with Scala or with with whatever, right? They've been burned, been told that XML, that there's this silver bullet that if they just change everything and adopt this new thing, life will be so much better. And so I definitely see a lot of reluctance. So
we've been burned, so we can only have compassion for that reluctance.
Yeah.
It makes sense. We should be skeptical because there are people out there who want to take your money and not give you the value that they promised.
Yeah.
That's a common thing. And and the only way to really understand it is is there a better way? Because it's like, well, it's what Jeremy and I are going to do in the next few days. We're having this Rust retreat, and we're going to delve in and analyze it and see, what is this thing that everybody's been raving about?
Right.
And programmers are raving about it. So it's like, well,
that's true.
And people that I trust. So I'm going, well, there's something in there. It's more, does it meet my needs? And I guess that's the thing. It's we have a tool that's going to meet everybody's needs. It's universally great. You should buy it.
Yeah.
Versus understanding that, well, your needs are different than others' needs. And
That's
maybe Rust is. I mean, I just read an article comparing Rust and Go, and this guy was a Go fan. But he was, I think he was, looking at Rust seriously.
Yeah.
But in the end, he's still biased towards Go.
Huh.
But maybe he's right, because it's
or
easier for a
needs.
bunch of things. Whereas with Rust, maybe like you're creating a particular kind of thing, and you go, well, that's what we want because of performance.
Right.
I don't know.
Yeah. I guess that's where its heart is. Value is in the eye of the beholder, or within your needs define what brings you value, and so it can be different for everyone depending on what they're building, what their team makeup is like, what their there's probably so many factors.
We're misusing the term marketing too, because marketing is actually figuring out what the customer needs, and it's gotten polluted to the point where it's basically, and even a good salesperson is someone who figures out what his customer needs and whether it's a good fit, and doesn't just push whatever product that they have.
Yeah.
So, but that's all gotten biased in the interests of
money.
Pretty much.
So we are seeing a lot of server-side Kotlin adoption. So we do see that.
But can you tell if it's new adoption or translating existing apps?
It's a good question. I don't know how much is new versus greenfield versus brownfield is the new.
Is that the term
I don't know if
now?
it's the new terminology, but it's. I've been hearing that terminology a lot lately.
Okay.
So you obviously know greenfield, but
Sure.
now brownfield is the taking some old thing and making it modern or whatever. And so I don't know what percentage of the Kotlin server-side adoption is coming via green or brown. It'd be interesting to know.
Yeah, to me that's probably the most critical question to ask. Maybe in your next poll, you can find that out.
So on Kotlin specifically, it's interesting to try to match needs and values with it specifically. So I'm thinking about one of the values of Kotlin is the handling of nulls, and I can see that that's a huge value. Oh, you won't ever get a null pointer exception again. But if you're in a brownfield application moving from Java to Kotlin, you don't immediately get that value. You actually have to rewrite all of your code and identify the things that could be null and make those things explicit.
I mean,
and
you
so
don't
I could see
have
that.
to. You can see every time I cross the boundary between Kotlin and Java, I know that what I'm going to get is nullable.
So everything is nullable, or
yeah. I mean, as long as you're staying within the Kotlin world, you can say.
But to
okay,
realize,
this is
to like actually gain that value, you actually have to write the Kotlin code that then handles the potentially null places. And so I can see that very different between that value is applied very differently between green and brownfield. Mm-hmm. Whereas there's maybe other things of Kotlin, other values of Kotlin that you would get without as much work or.
Well, when our friend Bill did an experiment where he created a Kotlin module for a large Java project, and he still benefited greatly from the non-nullability of what he did. It's just that when you hit the boundaries, when you're calling in and out to the rest of the Java thing, you have to do a little bit of extra work to say, okay, this is nullable, what do I do?
Right. Yeah.
And then there's the fact that they're using null for two different purposes, which it took me a while to get clear on that.
Yeah.
Because it's all about the non-nullability. And then within the Kotlin libraries, they will themselves return a null.
Yeah.
And you're going, wait, well, I thought we went to a lot of trouble.
Explicit nullability is what we should call it.
Yeah. And that's really more of and this was actually one of my questions, is that a variation of a monad.
Oh.
Because what you're doing, so if we look at a monad as a package of information that travels from one function to another so that we can chain function calls, then this kind of fits that, because when you call a function in Kotlin that can explicitly return null, you're saying, well, I can either get information or I can get nothing. I can, something failed, something didn't work out, or that thing isn't in your map or whatever. It's like, and it's really a message. And when you take the two together, it's basically an either.
Yeah.
So is that, it's certainly monadic thinking, I would say, but could you even call that a monad?
Oh God. I like the segue into monads. Could you call that a monad? So I get a little mathy when we talk about could you call it a monad.
Okay, so before we let you get mathy, let me explain the conclusion that I've come to about what a monad is. And the problem with the explanations that I've seen is precisely the mathiness.
Yeah.
And so what I'm looking at is what's our, as an actor would say, what's my motivation?
Yeah.
Why are we trying to do this thing? And the answer, I believe, is primarily we want to chain functions together or compose them. I think, it's kind of a variation of the same thing. We want to chain these functions together. Now, if we do it the old way, every function we call, we have to go, oh, what's the result of that? What am I going to do with it? And we have a whole bunch of code around it. And we don't have this nice composition where I can say A calls B calls C, and the result of all of that we do something with. We have to intercede. We have to intercede after each function call. This is the way basically Go does it. It says, okay, I'll return kind of either a result or an error condition in a single package. So that's the goal, and to achieve that, instead of just returning a result, we have to return a package of information which is passed on. And then when you get mathy, it's like, well, what are the rules for that package of information?
Yeah.
But starting at that point just confuses the heck out of everybody.
Yeah.
Because they're going, I don't understand. I don't even understand why we're trying to do this thing.
Yeah.
And if you look at it from the standpoint of, well, we're trying to do it so that we can
chain operations.
Chain operations, which is really an essential part of functional programming, is composition. We want to be able to compose functions together. And the only thing that doesn't fit that model is the monad when you are, you're trying to make everything invariant, and then you have the monad that changes things, that connects to the outside world or is the clock or something like that.
Yeah.
So what's wrong with that discussion? Is that at least?
Yeah, I think it's good. I think you are very right to identify that monads are a way to deal with chaining of functions or operations where you need something other than just the value. Right. Because with just functions, if you have a function that returns a value and then you want to chain that to that value to another function that then takes in that value and returns a new value, that's all great until that value needs some more information about it, something beyond just the value,
right?
Just the pure value. So in the case of error handling, you want to know the other information you want to know is, did this succeed or did this fail? Mm-hmm. And if you don't just return the value like this succeeded, but instead you return something that says, did this succeed or did this fail? And if it succeeded, here's the value.
Package of information.
Yep. Mm-hmm. Then now all of a sudden your function that you want to chain that to needs to take that that thing that holds the information about did this succeed or did this fail, and know how to extract the value out of it, or know how, in the case of failure, to move on.
Which makes sense to me when I put it in the context of the problem that we're trying to solve. But when you start with that and go, oh, well, it's a monoid in the category of endofunctors, and it's like, I don't know why we're doing that. But if you look at it if we start with this explanation, then you say, oh, and each function has to have a way to unpack it and then pass its own package of information along. Yep. Okay, so I get that now.
So to take this example further of air handling, all of a sudden then the functions that you want to chain on, your second, third, whatever functions, if we don't have monads, they would have to take as a parameter the thing. I don't want to call it a box or a burrito or whatever, but they need to take the thing with more information, and then inside of that function be like, okay, here's what I need to do if it's a success. Here's what I need to do with it if it's a failure. And it's good that you brought up Go, because Go has the air tuple returns,
which is just a convention.
Just a convention, but that requires if you were to pass that result to a function, you would, in your function, then have to look, oh, is this a success or a failure, and then decide what you want to do.
And I don't know, I haven't seen any examples of people doing that. I think mostly it's just call the function, check the result.
Yeah. So what if we had a way to chain operations together that inherently knew what to do if it gets a thing with more information, and could then provide a way to continue the chaining, to enable chaining with as much chaining as you want to do. Mm-hmm. And so I think that is a good way to look at monads. What I don't know is that the only way to look at monads. I think maybe some deeper functional programming language experts may say that's only one aspect to monads.
But when you look
maybe
at
not, I'm not sure.
The Zio library, it says, okay, we're going to handle errors, and you can attach environment, you can attach time, you can attach these other things to it, and we'll pass all those things through as monad calls, so you can chain your calls together, and it still seems to fit.
Yeah.
And it also, because when people start talking about burritos, it's like, I don't know, why would they choose that? Whereas if they'd simply said a package of information, that would have been, because why do you need to have the extra abstraction of a burrito? That's
right.
Somebody's being cute.
Yeah. I think I'm not totally sure if monads only involve the package of information, or if that is just a very common thing that we use them for. Because there's so many different places where monads get used, but I think ultimately the chainability is central and necessary, because I don't think you would ever use monads if you never wanted to do any chaining. If you for some reason a thing only did one thing and you didn't need to do any chaining of operations, I don't think there's any reason for monads.
No, I can't see that. The chaining seems to be, and I would say, well, it's everything that's necessary to make that chaining happen, but the easiest way to explain it to somebody at the beginning is to say, we want to pass this package of information. Then you get into it and you go, well, it'd be nice if each function had a consistent way to unpackage and then repackage that information so that it wouldn't be as much work for the programmer to do it, and they wouldn't have to think about as much stuff. And then you get into, well, what would that look like mathematically? And then you get mathy about it.
Yeah. We'll get mathy about it in a minute, but
okay.
I as far as I know, monads always do have a package or something beyond just the pure value. Mm-hmm. I haven't seen a use of monads where that's not true, but so what I find interesting with monads is that, some really smart people kind of saw this problem of chaining. They saw this problem of what's called like state monads. They saw this problem of chaining optional things, chaining success or failure things together. They saw a bunch of different things, and they said, "Oh, there is an abstract core idea that can accomplish all of those different things." And with I think in all functional programming and in math, when we find those abstractions obey mathematical laws, so that we know when we use it for this thing, we can be guaranteed that this is the behavior that we're going to get from that abstraction. And so that's where it gets mathy, is that a monad technically is just something that implements 3 different algebraic laws. And so technically that abstraction is just defined by the mathematical laws that it abides by. Mm-hmm. But I don't even think about the abstract mathematical laws. I use monads for all sorts of things, and it's
like the difference between physics and engineering. It's like, well, we figured out all these things in physics, and in engineering, I just want to weld the beams together and make sure that they're going to stay together. I don't need to, know the underlying physics of this thing.
Of welding, yeah.
Just, make sure the beam is big enough.
Yeah,
etc. And it's like,
and that weld will hold, mm-hmm. Based on your expectations of how
you have ways to test it.
But but knowing at the atomic level how the weld actually happens is not necessary. Mm-mm. It's that you can expect a particular result. You can expect a way for it to behave.
So, somebody did those equations once, and now we're going to rely on them.
Yeah, exactly.
Right, and so
somebody figured mm-hmm. it out, and now we can just use it and not have to understand the reason why the abstraction works. Mm-hmm. So it's probably not useful to talk about the actual like algebraic laws of monads, and I always have a hard time remembering them off the top of my head. But I think the important point is that there are laws that they abide by, which allow us to expect a particular behavior from things that are monads. Yeah,
it helps us engineer how we're going to chain these functions together, how we're going to compose them.
That's right.
And
exactly.
That's what we need to get to. But now I understand why it's been so confusing for so long, is because the mathy people came first, and that's how they explained it.
Yeah.
And
remember at the very beginning of us talking about monads, you asked like something around, is this a monad? And I think that there's 2 different ways that you can go with that conversation. But the math person in me wants to say the way that we prove that something is a monad is does it fulfill the laws, the mathematical algebraic laws of monads, and that's how we know if it's a monad.
And the engineer in me says, okay, if our goal is to compose functions, and this thing allows us to compose functions, then at least it's monad-ish.
Yeah.
It's got the basic ideas in there, which is that instead of just returning a result, you're returning a package of information, which in this case includes the result, and then this null to tell you that there wasn't a result or not.
Yeah.
And so.
And the ability for something to know what to do with that package and make a decision about what it returns. Mm-hmm. Because in back to your question of is returning a null or a value, is that monadic? And
Not by itself.
I would say no, because, well, we could talk about it on the math side and why it's not. But I think on the monad-ish side, is this even not monadic, but monad-ish? Then I would say no, because the way that we usually convey the package of information is through the type system. And in the case of your example of returning a null or a value, your type system is not actually conveying that information. The return type that you are returning does not convey that your two possible things are null or a value.
Well, plus there's no mechanism built into the. Well, actually, that may not be true. A lot of the functions may check for and handle nulls and pass that along.
So it's who needs to check that and decide what to do with that. And in the case of monads, my code doesn't have to check it doesn't have to check the package information. So my function that I'm operating on, my second operation on this package of information, doesn't have to look at the package information to decide what to do. And I think that's part of the difference with monads, is that...
So it's wired into each function to say, oh, well, this failed, I'll just pass it along. For example.
Yeah.
For example, I mean, lots of other possibilities, but
so in the case of a function that returns a null or a result, and let's say you even have Kotlin and that can be expressed in the type system, when you call a function that returns that, you need to do something with that. You need to actually have like a if and say, if this was null, then do this. If this wasn't null, then get the value and do this. And when things become monadish in this use case is when I don't have to do that checking. Right. I just say, okay, take the output of that function and give it to this function, and I don't have to do the checking about. I don't have to look at the package information.
You just do what you want to do, and the rest of it's automated. Right. Yeah.
And so one of the ways to do this is with flat map. So I provide my second operation. So I take something that has that package information and I call flat map on it and give it a function. And when I give it that function again doesn't have to look at the package information.
But that's a special flat map, right? That's not just any flat map.
It is so the flat
like
map,
you overload it, right?
So on the case of an option, option has a flat map function,
right?
And so when I call flat map on an option, that is where the monad decides, oh, if it was none, then I'm just going to return none. If it was some, if it had a value, then I'm going to apply the function that you gave me to that value, which can then, that function needs to return an option as well.
So each monad has its own, well, for example, flat map. It has its own defined set of operations to perform on itself, and the user of this goes, I'm going to assume you have, for example, a flat map, and I'm just going to call it, and you're going to do, it's kind of polymorphic, right? Because it works with all these different types. As long as they have a flat map, I'm just going to call your flat map. And
so different languages and technologies have implemented this differently.
Sure.
One way to implement it is to have a use inheritance to say, okay, if I inherit essentially from monad, then I get a flat map. And so then you can be sure that if you are dealing with something that inherits from monad, that it's monadic and you can call flat map on it. That's one way to do it.
Of course, you have to then override the flat map to do the appropriate thing for your
maybe or maybe not. But yeah,
sure.
Yeah,
the usual.
Yeah, monad is a trait. It doesn't have an implementation by default. So a list would have a different implementation than an option and so on and so forth. So that's one way to do it. The Scala Standard Library doesn't do it this way. The Scala Standard Library says if something has a flat map function on it, just a function called flat map, then we're going to consider it a monad.
Oh,
and
I see.
so what's interesting is if you look, so in the Scala standard library, there is no monad
Sure.
trait. There are a lot of things that have a flat map on them.
And so by convention
is how you know that things are.
And that's all it needs is a flat map?
I think it needs a flat map and a filter. Well, filter would be different. So where this actually matters is two places in Scala Standard Library. One is that in the documentation, it will say this is monadic. And so it's kind of like just conveying information to the user, like this is monadic. And then the other place where it gets used is that chaining these monads together is nesting, right? So if I have something that returns a monadic value, and then I want to perform another operation on it with a flat map, and then another one on that value, and then another one. I'm just doing this very deep nesting in my code, and it's kind of cumbersome and doesn't look very nice. And so, as far as I know Haskell, but maybe it came before Haskell, there was a language syntax that knew how to make dealing with monads look imperative so making it look. You actually structure your code like
first I do this, then I do this, then I do this, then I do this.
Yep. So make it look imperative. I do this and on different lines instead of nesting. Mm-hmm. And in Haskell it's called do notation. And so in Scala they created their own do notation thing that knows how to handle monads. And so when you are using the do notation, which is with a for, the for syntax in Scala, to get that imperative style of code, which reads and looks a whole lot nicer, in order for you, the Scala compiler enforces that in order for you to use something in that way, in that do notation style, it has to have a flat map method and it has to have a map method. And the reason why it has to have a map method is because when you get to the last statement in do notation, you don't call flat map, you call map. And so it's really just the syntactic sugar around the chaining through flat map and map to make your code look imperative.
Yeah, because a lot of, like even Java 8 kind of took on that. Do this dot, and then on the next line dot, do the next thing, dot, do the next thing, which I think originated from functional programming, that style of chaining things together.
So you can't do that with monads. You can't do that style of chaining with monads because the way that you chain monads is through flat map. And so that's why you get into the nesting with monads, is that you're not calling you're calling something that takes a function as a parameter. And so that's why you end up nesting deeper and deeper and deeper by default. Whereas in the Java style that you're talking about, you're not calling things that take functions. You're just calling methods on a thing. And so you can do chaining. And that would just be like function chaining basically without monads.
But you could. It seems like if each one of those returns, a package of information, then the next one could accept that and do something useful with it. Maybe not as nicely as what you're talking about, but it still could.
Yeah, could you have syntax that would give you like the dot notation across monads? Not with our current languages that I've seen, because the way that you operate on a monad is by calling flat map with a function that's going to do that next operation.
Which I see makes sense because you're wanting to have all of that internal scaffolding that you don't have to reproduce for each function.
That's right.
Right. So that makes sense. But now I'm also intrigued by this idea of being able to and see what the null versus value thing does in Kotlin, which is a compromise for sure, because they could have, they knew about monads. They could have gone full monad.
Yeah, they could have gone full monad.
Full monad, but they chose not to for the same reason that C++ is backwards compatible with C. I think they thought it was going to be too big of a shift.
Yeah,
but it does allow you to chain things together, and then each one can say, oh, if it's null, pass it on.
Yep.
If it's not, and let somebody else deal with it, or maybe even include say an exception that gets thrown, or some kind of error condition.
Yeah, so I've seen some discussion on Twitter around the Elvis operator and how in JavaScript and in Kotlin and other languages too, I'm sure, it was really just used for nullability and being able to walk through a chain of nullable things. Mm-hmm. But that is one specific place that you would want to do chainability. And one of the discussions that I saw was saying it would have been a whole lot more interesting if they had done that, enabled that syntax for anything that can be chained, basically through monads, instead of just for nullable things. And I thought that was interesting. I think what they would eventually have gotten to is something like do notation,
right,
for doing that chaining. But it was interesting that JavaScript and Kotlin only looked at that problem, chainability for nullable things, and they didn't look at, we might want to chain asynchronous operations in the same way, or we might want to chain other things, and other monadic things in the same way. And how can we generalize this instead of making it specific? The nice thing about making it specific to just nullability is that it constrains the problem and makes it a lot easier to learn and a lot simpler,
and to implement with the compiler and all that kind of stuff.
Yeah. Mm-hmm. And whereas do notation, much more powerful of a imperative syntax for doing chaining of things, because you can do it with anything with a flat map, basically. Mm-hmm. But at the same time, because it's so general, it is more confusing. I remember when you and I were first learning monads, we were confused. Well,
you were learning monads. I was confused about them for way longer.
But I remember we were specifically looking at chaining Scala futures with using the do notation, and were confused about something related to that. And so I think that in some ways the generalness of do notation and monadic operations in Scala makes it harder to learn and more confusing.
Absolutely.
It increases the surface area.
This is definitely, now that it's starting to come together for me, I can see exactly why it's so much more confusing, and why you don't want to drop all of that stuff on somebody right away, which is pretty much what everybody does. Yeah. And they try and mitigate it by going, well, it's a burrito, but that just confuses the situation, I think.
Yeah. Yeah. So one of the things that I've said a number of times around monads is I really think people should use monads for years before they try to understand what they actually are. Because I fell into the trap of, monads are so cool, and everybody's talking about monads. I want to understand what they are. And it really kind of threw me off from what I think needed to focus on at the time, was just use monads and learn the abstraction, the generalized abstraction later.
Yeah, well, it's essentially what I'm saying start with the motivation. It's like, how does this help me?
Yeah.
Before any of that other stuff. If I can see it mechanically working, then that's much more motivating.
Yeah.
But it's, I don't know if... I feel like you and I came up with the idea of the curse of the monad, but
that was Doug Crawford was the first one.
Doug Crawford,
and this was he said this 10 years ago or something,
I'm sure.
like that was when he coined that.
Okay.
The curse of the monad.
Yeah.
But yeah, right. You should say what the curse of the monad is.
Well, as soon as you understand what monads are, you become unable to explain them to anyone else.
Yeah, and we've been fighting that curse for going on 5-7 years now or something like that. We're gonna overcome it.
Oh,
I'm sure everyone is confused by monads that's listening right now, but because the curses so far.
I feel like we've made some progress here, though, because
Yes.
well, but at least I don't know. I could be just becoming cursed.
That's right.
I could just be going, oh, I'm starting to see it now. Oh, the clarity is fading away. I can't explain it anymore.
Yeah. So what now makes sense to you makes sense to no one else.
No, but I feel like, I mean, that's kind of my thing, is remembering what it feels like to not understand something. So I think I might be able to hold on to this long enough to.
Yeah.
It's still a challenge. It's not like I've cracked it, but I feel like some of these ideas that we've talked about here is.
So John DeGoes had a good kind of explanation of monads, which is something we've talked about already, but I want to reiterate. He said, I should have had the tweet ready, but he said something along the lines of, like, monads, what they're really about is allowing you to program imperatively in functional programming. And without the ability to do, without the existence of monads, in functional programming, there just is no way to, like, have something that looks imperative. So it's not really imperative because it's functions and the functions are just composed and chained, but you can make it look imperative with monads. And monads are the only way to, at least, actually I think there is another way that people have been talking about, but I forget what it's called. But anyways, it's the primary way that we've discovered to make functional stuff look imperative. And I don't know if that helps at all, but.
Well, it fits in with the model that I've been creating in my head. Whether it helps someone trying to understand monads from scratch is another question.
Yeah.
So, but I think, it's one of those things where I took a screenwriting class once, and the teacher was saying, so what you want to do is set it up so that when you hit this certain point in the story, in the reader or watcher's brain, it's like dominoes falling. It's like, oh, that means this, and that means this, and that means this, and I can sort of feel that happening. But I'm also trying to hang on to, but if you didn't understand anything about this, how would you gain entry? And I think the error condition is probably the most compelling one, because you've seen other approaches to try and handle errors. Yeah. And I just kind of an aside, one of the Kotlin designers had a nice blog post in the last month or two, and they were talking about exceptions. Yeah. You know which one I'm talking about. And he made some very clear distinctions about, here's where, because when they were introduced into C++, I was on the committee then, and I was trying to figure out, what is this? This doesn't look anything like what I'm used to looking at. And it was supposed to handle all. It was the unified way of reporting errors, and the goal was ultimately to be able to recover from errors. Yeah. And I think what this blog post pointed out was, there are such things as recoverable errors, but they're really rare. And then everything else is really just reporting, and the exception, using an exception whose primary goal was recovery to do everything, was a mistake. Yeah. And then Java took the mistake and ran with it.
Yeah. And now Kotlin did too.
Well,
which
Kotlin
we're going to talk about with Cedric next week.
Oh, yes.
So that's one of his topics. He wants to revisit some things we talked about with Kotlin. Yeah. And the exceptions is one of them. So there'll be more about that.
And they didn't, I would kind of guess they would have probably, if they were able to start from scratch, they would have narrowed them down to be used for things that you could actually recover from, and then do something else for everything else. Yeah. But they had to, they're working on the JVM, so they had to deal with that. What Java does. Yeah. So, but they don't have checked exceptions. So there are no checked exceptions added in Kotlin.
Yeah.
And they don't respect checked exceptions from Java. So
Interesting.
there is a change there.
So this is similar to a conversation that I had with some folks who were building a UI framework, and this UI framework, it was using mutation, like hidden mutation, to chain things together. And when I saw it, I was like, oh man, like I wish they would have used monads for this instead, because monads are just such a great way to chain. No, some other one. I don't want to disclose because I'm going to talk dirty about them and air. So I talked to some of the engineers, and I was like, why didn't you all use monads for this instead? Monads fit this so much better. And they said, well, monads are too complex, and no one would understand it, and all that. And I've wondered if that attitude towards monads, which, yes, monads, they are, like, as we've experienced, like, it's not the easiest subject, but I wonder if the attitude towards monads of, oh, nobody can learn it and they're too hard, has actually propagated using inferior design choices and kept people from something that they really should do, like kept people from the way that they should be doing things, the better way. And I know this is always hard, and there's, it's hard to always know when you should go with the better way or not. But with monads, I'm always like, God, we should just like get over this monads are hard thing and just use monads where we should use monads. And where it relates back to your previous conversation is like, God, I wish Kotlin would use monads for their return types, because it just is so much better of a way. And yeah, people are going to have to learn monads, and that's going to be hard. But wouldn't we rather them learn the better way to do this than propagating the wrong way, the exceptions and that messiness?
Well, I can't say I've ever seen an article which like says, here, use, because you keep saying it, you go, people should just use monads. Well, I haven't really seen an article that says, here we are using monads, see how easy it is. Don't see that a lot. And I think that's the direction that it needs to be taken from. Yeah. But do you know of any languages that are being developed that are using monads as first class, integrated?
Elm is one of the most recent ones, and then I think that,
but they don't talk about monads in Elm.
It's true, they don't really talk about monads, but yeah, it definitely is.
And there is, from what I studied of Elm, there was like, well, we do all this stuff, but the mutation happens in this hidden place. And it confused me. I still was, but I assume that's the monad.
It's all monads. Okay. It's been a while since I've done Elm, but I remember they had like this pipe operator thing, and the pipe operator, I think, was like their flat map, essentially, saying like, take the results of this thing and pass it on to this other thing.
Yeah, they do.
So I think that the pipe operator is essentially their flat map, but it's been a while.
But that was pretty straightforward to look at.
Right, and so what was interesting is I think you're right. They didn't actually talk about that as being monadic.
They were very careful never to use the word monad.
Yeah. Other languages, all the like Haskell derivations, of course, are all
because
based
Elm was basically
monads.
A copy of Haskell.
Yeah.
So
I think anything that kind of has its roots in Haskell is going to be monad kind of first. And then I've started to do some exploration into Unison, which is I'm so enamored by Unison, and we should do an episode with them. But I think that a lot of what they're doing is based on monads. But I haven't done enough with Unison to kind of know how foundational that concept is.
Mm. So. And is that? I thought that was still like being developed. It's not. It's like ready for prime time.
It's very early days for Unison, but we should do an episode on Unison and get Runar One of those guys from Unison on, because I think Unison is the most innovative thing to happen in programming languages in a really long time. So, but anyways, what else on Monads are we? We should leave listeners with some monadic advice or something like what do you like? People I think are interested in monads. I don't know. My advice is use them. Just use them. Like when I started doing Scala,
I don't know what that means though. Just use them.
Well, I guess like in the case of Kotlin, monads are not used very often, and so.
But there are. I mean, there's some articles showing here's what a monad would look like,
and there's Arrow, which is the functional
that's it.
library for Kotlin.
That's monadic.
Yeah.
Okay.
Okay. So you certainly can use monads in Kotlin, but it's not kind of the default.
It's not a
path.
first class.
It's not in the core language and standard library like it is in Scala. So use monads. Like a lot of people aren't really in a place where they can, and so or in a technology set where they can. So that's not good advice. I don't know. We'll keep trying to explain monads.
Yeah.
Whether or not people can use them.
Yeah. No, it's been an interesting challenge, but I'm starting to see it.
Yeah. Well, and I think once you see that with functional programming, if you want to program in an imperative style, you really have no other option. And then I think when you get to like the highest level of enlightenment, you see mathematically why the laws are required to enable that. I'm not quite there yet. Okay.
All right.
That was fun. Thanks for listening.